Okay, welcome to video number 24 of the Diaries of a Coronavirologist YouTube channel. Today is the 27th of May, and we are just under 5.7 million confirmed cases of COVID-19 and a little bit under 355,000 confirmed deaths. A major milestone was passed here in the USA today with over 100,000 official deaths. For the video today, I'm just going to do a quite quick one. As I've said in my last couple of videos, I'm lining up to do a discussion about the origins of the SARS-2 coronavirus and to tackle some of the questions surrounding whether the origin is from a lab. And that's a contentious topic, so I'm really taking my time to prepare things and lay out my arguments in clear detail as to why I think this is a naturally evolved virus, not something that's come from a lab. But because I want to prepare it properly, it's taking a bit of time. So therefore, just to put something out there in the meantime, I'm going to do a little prelude video to talk to you about the safety levels that we use to protect ourselves when working with coronaviruses in the lab. I'm not just doing this as a way to put my parents' mind at ease for working with these viruses. It's actually something I've done in the past a few times before SARS-2 was a thing, down at the Smithsonian National Museum of Natural History in Washington, D.C., where I take people through the PPE we wear and talk a little bit about how the lab is set up to set everyone's minds at ease. We really do try and look after ourselves, and we have lots of layers of protection to make sure that we don't infect ourselves and inadvertently bring the virus out ourselves. So I just want to talk to you about the way we protect ourselves, like I say, as a prelude to go into the topic later in the week about the origins of this virus. So come with me now and see a different part of the lab. So welcome to a whole new style of me filming these videos where I stand and hold the camera myself. I'm currently in the anteroom for our BSL-3, so the sound's going to be different and there may be a little bit more background noise based on the machinery that's running, but there's little I can do about that at the minute. First things to point out about this room are that it's a key code and key locked room, so only people who have gone through the appropriate training that we trust to work with these viruses can actually work with these viruses. So we keep everything very locked away and safe behind multiple layers of protection and locked doors. The other thing to note is that this room is under negative airflow. So nothing airborne from this room escapes out into the rest of the university. The actual BSL-3 containment lab is similarly under negative airflow, so anything airborne in there can't come out into the anteroom, and anything in the anteroom can't go out into the rest of the university. So things that are airborne are totally concealed within the BSL-3 lab. So there's already 2 layers of airflow protection there. The next layers of protection that are important for us are wearing the appropriate PPE. So first up is the fact that no street clothes can enter the BSL-3. We wear scrubs the whole time we're in there. So pretty typical scrubs and Crocs, and I hate wearing Crocs, so I always point that out. But this means we have 1 layer of protection should anything go wrong. Should we rip our suit or anything like that? Not that this happens, but we are not wearing clothes that we could then take out and contaminate the environment with. We wear clothes that we can very easily destroy and replace, should we need to. We then have our first true layer of protection, which is a pair of gloves, the white Tyvek suit, the white onesie, and some shoe covers to give us that outer layer, or our first outer layer of protection. The final clothing layer of protection comes in the form of a big old apron and an extra pair of gloves. So at this stage, there are scrubs, a Tyvek suit, an outer apron, shoe covers, and 2 pairs of gloves, all protecting us from the room we are working in when working with coronaviruses. One important final piece, though, is airflow. And for that, we use PAPRs. So this is PAPR for Powered Air Purifying Respirator. So I think now everyone is well aware about N95 masks and surgical masks and all these ins and outs. We go even further. We use PAPRs. So here, air gets sucked through a big HEPA filter, gets purified, and that gets blown up into the hood that we then breathe the air through. So we're breathing completely clean air because it's being purified through the HEPA filter. And we're actually in a room that is under negative airflow, so things are being sucked out of that room and through a HEPA filter anyway. So we're very much protected from anything that may be aerosolized in the room. Not that we, in principle, aerosolize anything in the room anyway. As I'm about to show you, there is another layer of protection before we even get to the viruses. But before I show that final layer of protection, I just want to stress the fact that these outer layers, so the apron, the outer pair of gloves, and the shoe covers, once they go into the BSL-3, they don't come out. They get completely sprayed down with ethanol, and then they get destroyed as a way for us to remove the waste. We don't walk out in those. Obviously, at that stage, we're then just in the Tyvek suit and the Crocs. But once again, we spray everything down with ethanol. So this is a really good way for us to disinfect ourselves. So ethanol is essentially what goes into the hand sanitizers that you should be using. So they're about 70% alcohol, and we use 70% ethanol as a way to disinfect ourselves before we walk out the BSL-3. So we essentially take a big old shower using spray bottles. So the final important part of the protective process is that we actually only ever work with the virus in a very contained environment. So yet another layer of airflow protection. And obviously we handle the virus, but that's in the outer gloves, which we constantly spray with ethanol. So if everything is followed correctly, which we ensure it is, nothing ever comes out of the biosafety hoods. So the biosafety hoods are our final layer of protection. And because I want this channel to be accessible to everyone, so anyone who is unaware of what a biosafety hood looks like, it's something like this. So we work within these kind of environments to make sure that viruses are only ever within that kind of environment where there's airflow being sucked out and through another HEPA filter, which gets rid of all the virus particles that may have been aerosolized. But again, we do everything we can to minimize the aerosolization. And then we're in a room under negative airflow, which sucks everything out through HEPA filters, again, if there were anything. We douse ourselves in ethanol. Like I say, we essentially take a shower in 70% ethanol, completely covering ourselves and all those outer layers of protection that get left in the lab to then be destroyed by high temperature and high pressure. And then when we walk out, there shouldn't be any remnant virus anywhere in the room. And just on the off chance, we spray ourselves all down with ethanol again. And that's how we work safely with coronaviruses. This was obviously a very different style of video today, and I don't think I'll do any more like that in future. I don't know what I would need to do ones like that for. But I wanted to use it to illustrate the kind of levels we go to protect ourselves and, by extension, protect anyone we may come into contact with. To really stress this idea that we do take this seriously, and people around the world take this really seriously. Biosafety is no laughing matter. And I'm using this because in my next video, I will be talking about potentials for lab release to discuss why I don't think it would have happened. So I want to show you the kind of protections and precautions we have in place, let alone all the medical monitoring and all that sort of stuff that we also have that I'm not even going into. That was just the PPE. So probably not my most interesting video, I'm sure, but I want to just show it. And again, I want this channel to be accessible to scientists and non-scientists alike. And I want, therefore, everyone to understand the kind of levels of protection we take, because obviously this is something that's being talked about a lot at the minute, and we do take it very seriously. Anyway, that's all I've got for tonight in terms of the topic. And I do, however, have one question, because as I've alluded to in my last few videos, I am toying around with the idea of answering people's questions if they leave questions down in the comments. So allow me to line up the question. So the question I'm going to tackle tonight was posted on my previous video, which was talking about the Chaddox vaccine. And the question regards a different vaccine, which is the Moderna vaccine. It's referred to as the USA vaccine in the question. So I talked about the Moderna vaccine back in video number 15, which I'll link to down in the description for this video if anyone wants to go back. But in brief, it's an RNA-based vaccine. So mRNA gets injected into people, it gets into cells, the cells then read that mRNA and produce the spike protein of SARS-2, which elicits an antibody response. And the reason the question was asked is that Moderna put out a press release on the 18th of May to discuss their phase 1 trial. Now, I wish I knew who said this first. I wish I could credit the original person, because I've heard it in a lot of places, and I think it's great. We can't do science by press release. So no data has been released, just what Moderna are telling us the results are. So it's hard to properly assess what they're saying. But to tell you what they're saying in a bit more detail, the trial was set up for 3 dose groups of 15 people each. So there's no vaccine control here, just 3 different levels of RNA getting injected into people. And what Moderna have said is that all 45 of those people produced antibodies. We don't know what those antibodies are. We don't know if they're good. We don't know if they're bad. We don't know if they're specific or anything like that. But all 45 produced an antibody response following injection. We also don't know if it's specific to the vaccine since there's not a control. So this is why I say you can't do science by press release, because there's a lot of questions that we don't know the answers to from what's being said. The better news, though, from it is that 8 out of 8 people produced neutralizing antibodies. So obviously 8 out of 45 isn't masses, but this was released before they had all the data, I guess. So they took the first 8 people, and this was 4 from the lowest dose and 4 from the middle dose, and all 8 of those produced antibodies that could inhibit the infection of the virus of cells in the lab. So if you take sera from people, you mix that with virus in the lab and try and infect cells, you find that the addition of the sera from patients is capable of inhibiting the virus's ability to infect cells. And that's good. That's what we're looking for. We're looking for this neutralizing antibody response. So it's great that the 8 people they've looked at in their 2 lower doses produce neutralizing antibodies. Obviously, we want to see more. We want to see that all 15 or all 45 people produce neutralizing antibodies. That's ideal. That would be ideal. It's also good that the lower dose seems equivalent to the middle dose, because obviously the less amount of RNA that's needed, the more doses you can produce. If you need half the amount of RNA to produce the same response, you can produce twice as many vaccines. So it's promising, but we need to know more, basically. Right now, there's nothing for us to look at. It's just what we're being told, and it's only a small subset. But Moderna are moving forward, and this is good. The more options we have available, the more vaccines we can produce. If they all work, then great. We've got multiple options as ways to tackle this outbreak. And that's where I'll end the video for tonight. As always, if you're taking value from these, please remember to subscribe and turn on notifications so you know when I've put up a new video. Share it with people who may also find it useful. And please keep leaving comments and asking questions. As you can see, I'm trying to incorporate questions in. So if you've got things you want answers to, feel free to leave it down in the comments to this video. As I've said, my next video is going to be talking about the origins of this virus. So if there's specific things you want me to tackle in that, please feel free to leave them in the comments. As always, please stay safe, wash your hands, and keep calm and carry on. We will get through this pandemic.